All right, let's get started. Welcome to the session on functional programming in Kotlin. I'm going to talk about a little bit about functional programming and then show a few things we can do with Kotlin in terms of writing functional style code. And I'll also talk about what it means to be functional along the way as well. If you do have any questions or comments, I'll be thrilled to hear from you. Just begin speaking. Even though if I may be looking at your direction, I may not be paying attention to you. So draw my attention and then speak up. I'll be more than happy to listen to you. So with that said, let's get started. Well, one of the things about functional style of programming is that it gives us an ability to solve problems by reducing quite a bit of complexity in code. Well, let's talk about imperative versus declarative and then a little bit about functional style just to set the stage for what does it really mean to do this. Well, in the imperative style of programming, we show what to do, but also we tell how to do it. So the entire burden of writing the code with all the details falls on our shoulders. So let's look at an example really quickly. I want to take numbers as an example is equal to list of. Let's go ahead and say I have a list of numbers, let's say 1 to 10. So given all these numbers, list of 1 to 10, what I want to do here, let's say, is to total of total of, let's say, double of all even numbers. So I want to compute the total of double of all the even numbers. How would you go about doing that with the imperative style of programming? Well, you would typically create a variable to hold the result. And that's the first smell. You got to create a mutable variable to start with. Then you can say for, and you can provide a number. And then number coming from numbers, if you will, which is this collection of numbers you want to deal with. When you are done with this, of course, you want to eventually print the total, and we haven't really done any totaling yet, so it is 0 at this point. But what you can then do here is you can say, if the number that is given to us is an even number, so you can say mod 2 is equal to 0, and if it's an even number, then you can say a total plus equal to the given number times 2, and you can then start totaling the double of all the values in the collection. So when you look at this, that is quite a little bit of code to write, where we have to loop through and write all that code, telling how to perform the product, how to perform the total as well, and how to add them back to the collection. All the details sits on our shoulders. And that is the imperative style of programming. We all have done that in languages before. Kotlin does not prevent you from doing it. If that is the right choice for you, you can still do that in Kotlin. The declarative style of programming is where you focus on telling what to do and not how to do it. So you can simply say what you want rather than detailing the steps of how to do it. So this is like talking to an adult, and you are able to say, get me some water, and you don't have to explain to them how to get the water. They know how to get it. So you're calling functions that can do the work for you rather than having to spend time on low-level details. If you look at the code we just wrote, you had to say how to perform the total of the product. You had to write that piece of code rather than just directing to say, go do this for me. So declarative style is where you can focus on what and not focus on the how. Well, the nice thing about functional style of programming is that the functional style of programming gives you the ability to move a little further with those details. I'm going to save this along as we speak, so I'm just going to say imperative right there and save it. But I'm going to talk about the declarative style. What does it mean to be declarative? Well, to understand what declarative means, so imperative is where you tell what and also how. Well, declarative, on the other hand, is tell what and not how. So you're able to focus on just the what. That's your goal when it comes to doing that. Now, what is really cool about functional style is declarative plus the use of what are called higher order functions. So this gives you a nice way to build on the concepts of functional programming with declarative and bringing in the higher order functions. So that begs the question, what does it really mean, higher order functions? Well, I'm going to say, first of all, normal functions. I don't even know if it's right to call something as a normal function, well, non-higher order functions. So a normal function or regular function, what does it really mean? Well, we pass object typically to functions. And we do this all the time. We pass objects to functions. And so these are normal functions. We create object in a function. So we do this also quite often. And then finally, of course, we return object from a function. And these are the things we normally do when it comes to programming. We pass objects to functions, we create objects within functions, we return objects from functions as well. But on the other hand, when it comes to a higher order function, what it means is that you can take this idea and you can go a little further with this, and that is we pass function to function, we create function within function, and also we may return a function from a function. And that's what makes a function a higher order function. So a higher order function is a function that may not just receive, create, or return objects, it may receive, create, or return functions as well. And one of the cool things about doing this is, in addition to doing object composition, we can also do functional composition. Now, if you really think about it, if I were to think about object-oriented programming, I could say that here is an example of a bottle. But from the OO point of view, object-oriented programming point of view, what is a bottle made up of? This is what we call as aggregation. So aggregation says this bottle is made up of, the container is plastic, it contains a nice label, it also contains a lid, and maybe it contains liquid inside of that. So you can say there are 4 objects that came together to create this one object, which is this bottle. So just like how you can perform object composition, you can also do functional composition as well. What that means is, if this were a function rather than being an object, and if this was a function rather than being an object, you can take these 2 independent functions and you can merge them together and you can create a composite function. And this becomes a functional composition. So when you pass the data to the first function, it can evaluate the data and send it to the second function, so the data can flow through these functions and you can perform the sequence of computations. So just like you can perform object composition, you can perform functional composition as well, and combine functions as it might be useful. So this idea can be taken further into programming. So I'm going to say this as declarative and functional, if you will. And that is basically the power of this kind of programming, is you can bring these ideas together for these kinds of functional and declarative style of programming. Well, given this, of course, this leads us to, how do we pass a function to another function? Well, for passing functions to another function, we must be able to represent this function, but more important, we must be able to get a reference to a function. Because if you can get a reference to a function, you can then pass it around, like you can get a reference to an object and you can pass it around. So this is where lambdas really come in. So what is a lambda expression? A lambda expression is an anonymous function. That's what it really is. So what does it mean, an anonymous function? Well, typically, what do functions really have? So you can say that a lambda expression, so you can say lambda expressions are really anonymous functions. So anonymous functions, and in general they are also expected, you could say, to be pure functions. And what we mean by expected to be pure functions is you don't mutate these data, you don't have any side effects within these functions. So in general, you want them to be pure functions. So lambda expressions are anonymous functions, and they're expected to be pure functions in general. That's your expectation based on lambdas. But a lambda is a weird name. Why in the world would they call it lambda? So lambdas, because these were just symbols given to expressions in the mathematical term, just like you and I would maybe write an equation, and you may call it x, y, or z. Well, they decided to call it a lambda. So there's no real significance to the word lambda per se. It's just a symbol. And so lambda expressions, on the other hand, are anonymous functions. But from that point of view, you could say, what does it really mean for a structure of a lambda expression to be the way it is? So for that, let's say a normal function. has 4 parts to it. It typically contains a name. It has a return type. It also has potentially, you give a parameter list, so parameter list, and then finally, of course, you write a body of the function. So these are the 4 things you normally provide for a function. Imagine you're on a trip and you're allowed to take only 2 luggages with you and not anything more. So what can you minimally take is the question. So from a Lambda expression point of view, you can say Lambda expressions only have 2 out of these 4 things. Now let's think about this for a minute. Lambda expressions are anonymous. They don't have a name. So as a result, they are pretty much returned without any name. You could assign them to a variable, but lambdas specifically don't have a name. But if you were to look at these 4 things, what is the most important thing of these 4 things? We can agree that the body is the most important, because without the body, what is the point of even writing a function? So a lambda expression contains a body. But in addition to that, it also contains a parameter list as well, because you want to know on what to work on, what to operate on. So as a result, you would typically give a parameter list. Hey, what about the return type? Well, the return type is inferred for a lambda expression, and you're not required to specify the type. You could optionally specify it, but oftentimes you don't have to provide the return type. That's figured out on context. So that is basically what you have. So from that point of view, what is the structure of a lambda expression? Well, the structure of a lambda expression varies depending on the programming language that you use. But in the case of Kotlin, similar to Java, you have a parameter list and an arrow separated by a body of a function. But in the case of Kotlin, you wrap them into a curly braces. So this is basically the structure of a lambda expression. You have the curly braces, you have a body, a parameter list of the lambda, you have an arrow that separates the parameter list from the body. Now, generally speaking, you want the body of the function to be a 1-line body. If you're going to write a multi-line body, that's generally not a good practice. As much as possible, you want to keep the lambdas as small as possible. Now, what if somebody wants to write a very large lambda with many lines in it? Well, you unfortunately lose some of the benefits of using lambdas when you do that, because one of the nice charms of lambda expressions is it's easy to understand the code. And when you walk through this functional pipeline, you don't want the lambdas to disrupt your flow of reading. So you want to keep the lambdas as much as possible to a single line of the body. What if you really are figuring out some code and you feel like you have to write a multi-line function for a lambda? My recommendation is immediately call for help and tell people that you're really having bad thoughts and you need some really serious help. So ask for help and avoid writing long lambdas. Generally, I would say that's not a good idea. There are exceptions to the rules, but in general, think twice or thrice before you write long lambdas. So that becomes the structure of a lambda expression, and you can write those structures very nicely. Let's talk about using lambdas to solve the problems we want to solve. So let's say for a minute, we have this collection of numbers we want to start with, and given the collection of numbers, how would we go about, iterating and printing the numbers? Let's take something really simple to work with first of all. So given this collection of numbers, all I want to do is print these numbers. So what I can do here is I can simply say print and print line and number, and I can print it. Now, while that code is an imperative style and the code works, this is looping through, and you are writing the loop to go through every single element. These often are called as external iterators. So external iterator is where you manage the iteration. You are writing a for loop and saying, go to the next element, go to the next element, go to the next element. Well, typically the signs of this are you would write continue and break and things like that within the loop. That's a sign of you controlling the loop in addition to saying what to do for each of the elements in the loop. On the other hand, what you can actually do is you can use what is called an internal iterator, which usually is the functional style of it. So internal iterators, in this case, you can start with numbers.forEach, and you can say, given an element that is given to you. I'm going to write this a little bit more traditional, and we'll come back and talk about this a little bit later. So I'm going to take an element, and I'm going to print that element out in this particular collection. So what am I doing at this particular point? I'm taking these numbers as the collection and iterating over the numbers one at a time, and I'm simply printing it out. Let's make this a little smaller so it's easier to see what the output looks like on the screen. So you can see that it printed 1, 2, 3, and then it also printed 1, 2, 3. So this shows you how you can use a very concise code to write internal iterator to loop through and print the value. Now, I've used a code which is a little bit verbose here. You can minimize the verbosity quite a bit. We'll come back and talk about this in just a few minutes. But this shows you an example of how you can use lambdas. In this case, you're not really, you're creating and passing a lambda to this code, but that becomes a really nice way for you to use this lambda expression. So in this case, that is your lambda expression. What can you say about the ForEach function? Well, the ForEach function is a higher order function because unlike println, which took an object as a parameter, ForEach is taking an anonymous function as a parameter. So as a result, the ForEach is a higher order function. It receives a function as its argument, as its parameter, and so it's a higher order function. Now, what you can do with this is a few different things. And the first is you can use the implicit parameter to this particular function. So what you can do here is you can say, rather than calling it as E, you can simply say it. So by using a it, you are avoiding passing an explicit parameter in the case of Kotlin. So this code right here is equivalent to a parameter coming in and that parameter being used in here. And that's what you are saying is just use that parameter in here. So you can either receive that parameter and use that parameter's name in here, or you can simply say, assume that there's a parameter called it, and I'm going to just use it over here. And of course, if you're doubling the values in this collection, you can do a ×2, much like you can do a ×2 here as well. So that's a very similar way to write that code. Becomes a lot easier to work with it. So you can either receive a parameter explicitly or use it. So when do you choose what to do? If your lambda has exactly one parameter, then you can easily use it. But if your lambda has no parameters at all, or it has more than one parameter, then it doesn't make sense to use it. So don't try to use it1, it2, it3. That doesn't work. So simply just leave it and give a name and use that name. What about the name itself? You want to give a sensible name for this. So rather than calling it K, Z, and W, you want to give a fairly good name that is meaningful. So if it's a collection of people, you can call it person if you want to, and so on. So decide on a fairly good name so it becomes easy for the programmer to read it. So that's an example of using an implicit parameter in that particular case. But if a function is fairly simple, you can use what is called a function reference. So let's look at this example for a minute. If you take this example, what you're doing is you're taking the parameter and you are simply passing it to the print line. You're not doing anything really useful. So these kinds of lambdas, I would like to call them as pass-through lambdas. A pass-through lambda doesn't do any real work. It simply takes an input and passes it to something else. So when you're using a pass-through lambda, it could be passed in as an argument or it could be passed as a target. But the point is, you're not doing much with it. It is just a pass-through. If you're dealing with the pass-through lambda, then what you can do is you can say for each, and you can use a function reference rather than using a lambda explicitly. So this becomes a nice way to reduce the complexity or the verbosity in the code. So the pass-through lambda simply says, if all I am doing is receiving the parameter and just passing it to another function, then simply put double colon and the name of the function. If, of course, it belongs to a class, you can refine that colon with the class name, object name, and things like that. So there's a way to use a reference for that too. Now, a pass-through lambda makes only sense, a function reference makes only sense when you're using a pass-through lambda. If you are doing some other operation with the parameter, like I'm multiplying it with a value of 2, I cannot use a function reference, obviously, because this is literally to say, just pass through to the function. I don't have any extra work to do. So what's the moral of the story? The moral of the story is use function references as much as you can, because it reduces the verbosity in the code, becomes easier to read it, less noisy in the code as well. So this should be your preferred first of all. If you cannot use a function reference, then use it when you write your lambda, because that reduces the noise of receiving that one single parameter if that's what you have. So use it. When you cannot use a function reference, when you cannot use it, then and only then provide explicit names for parameters and then write your lambda. And when you do, please give meaningful names that are easier for the programmers to understand. If you're not able to give a good name, try gravitating towards using a function reference if possible. That way you can get rid of it. That's a lot better. So that's an example of using a function reference in here as you are writing this. Now, what about receiving a lambda? We talked about passing a lambda so far, but what about receiving a lambda? If I want to get a lambda on my hand from as a function, creator of a function. But before we talk about receiving a lambda, let's talk about assigning a lambda to a variable and then calling into it. So to understand this, let's take a slightly different example. I'm going to say over here, print it, and then is equal to. Now, when I call printed, it appears like I'm going to define a variable, in this case, a constant. But because your functions are anonymous functions, you can treat functions as objects. You know how you can pass a function to a function, just like you pass an object to a function. You can start treating functions like they are objects, and as a result, you can store them into variables. So in this case, I'm going to take this function. What is the function going to receive as a parameter? It's going to receive a number, integer, as a parameter. And what do I want to do with that parameter I just received? I'm going to just print it. So I'm going to say print line number. So the print it is going to simply receive that and print it. That's all it's going to do. So I'm just running this code and seeing what it's going to do. Well, it says cannot infer the type of this parameter, specify that explicitly, it's complaining. Well, in this particular case, as I'm defining this, what is the type of the function? Because I'm assigning a lambda, I want you to take a look at this for a minute. It is complaining that you want to give a little bit more information about the type of this particular variable. So what I'm going to do in this case is, I'm going to say that this is going to be receiving an integer. It is going to return a unit. It doesn't have any return type. It's a void, which is a unit type that I'm going to return, and that's what I'm going to specify over here. And of course, in this particular case, I can leave out. So let's remove this for a second. This is going to be the number coming in, and then I'm going to return that particular result for us. Now, in this particular case, the number is an integer. What if I leave out the int from here? Well, when I leave out the int from here, you can see it is still happy with it. What if I put the int over here, and for a minute, let's remove it from here again, and run this code. And in this case, of course, it was okay. So the parenthesis I put was not really happy for it. So without the parenthesis, it is quite happy. So this is one way to define it. Alternatively, you can remove the type from here, and if you remove the type from here, this won't work because obviously you're not telling what the type of number is, but you can come in here and say, this is going to be an int over here, and then it returns a unit at this point, and that will work as well. So which one do you use among the two? I would prefer personally the format over here on this line because that's less noisy. So I would rather specify the type in the parameter rather than for the variable, and that way I don't have to worry about the return type that gets inferred in this case. You can go either way. How do I call this one now? So to call this now, I'm going to call print it, and then I'm going to send a 4 over here, and as you can see, it is just simply printing the value 4. So that's a way for you to invoke this. So this is simply storing that into a variable. That's all we are doing. In fact, let's put that away here as storing lambda into a variable, right? That's what we did. We just stored it into a variable at this point so we can use that for other purposes, like calling a function on it if you really wanted to. But on the other hand, you can receive lambdas as parameters to functions as well. So how do we receive lambdas to functions? So to receive lambda in functions, let's create a function that would use it. So what I'm going to do here is to write a function. We'll call it as compute, and the compute function takes an integer as a parameter. I'm going to do some computation. Then I'm going to say action. And in this case, the action is going to receive a double value, and it is going to return nothing, which is a unit. So now we are saying that a compute function takes 2 arguments. It is going to take n, which is an input integer, but it's also going to take a lambda, which is an action. And when you say action, well, notice n is an integer, you said that. But action is a function, anonymous function. So in this case, you say it receives a double as its own parameter and returns void, a unit, which is representing void, and you're saying that's what it's going to return from this. Now within this code, you can say action, and you can pass some value n times 2 to it. And you could say 2.0, for example, 2.1, whatever that you may want to pass. So you can take the value and you can pass that value as a parameter to that particular function. How would you go about using this? Well, in order to use this, I can say compute. I can pass a value, let's say 7, and 7 times 2.1 is going to be the result of that particular call that you're going to get. But the action is going to be, let's say, result, and all I'm going to do is simply print the result at this point. And of course, that's a lambda, and we know that we have to take the lambdas and wrap them into curlies. So I'm going to put a curly right here, and I'm going to wrap them right there. So that gives us the result of that particular computation. So you can see in this case, we pass the value 7, and we pass the lambda to this function. Now, that's a little verbose code. We'll come back and talk about this in a few minutes, but that gives you an idea about how to pass lambdas, but more important, how to receive lambdas as arguments. So in this case, of course, the compute function takes one object, n, and a lambda action as its parameters. As a result, compute is considered to be a higher order function. And that's what we saw, how to receive lambdas as a parameter in here. That's what we saw in this particular example. Well, good so far. But when you look at line number 5, it looks a little cluttered. But before we go further, let's talk about a couple of differences you can do. You can create this function, and you can argue, maybe I'll put an action, comma, and I will put a n:" integer. So I'm going to take a lambda first, and then I'm going to take an integer value after that. Well, if you write the code like this, then of course, you're going to pass the code 7 like this. While this code will work, this is pretty noisy. Well, but this is the consequence of taking lambda in the first place, or the first position in the parameter list. Now, that's the only choice you have. On the other hand, if you write the function compute a little differently, as in if you were to go to this function and pass the lambda as the last argument, so you basically say n, comma, and then in this case, you're going to put the lambda as the very last argument action. Well, if you do it this way, when you call compute, you can obviously do the following, and we saw this work a few minutes ago. However, there is one benefit to taking lambda as a last argument. If you take lambda as a last argument, then instead of the above, what you can do is you can pass the parameter 7, close the parenthesis, and you can hang the lambda right outside like this. Now, this is possible only when the lambda is the last parameter. So when the lambda is the last parameter, it gets a special privilege. And I often say this case of treating the last parameter differently is like how parents treat their last children very special. You know that, right? I know it very well because I was not the last child. And I know the conspiracy against this. Well, that's exactly what's happening here. It says this is the last parameter. Oh dear, that's so special. So as a result, it gets treated very, specially. You can close the parenthesis, don't need to have a comma, and then you can put the lambda right outside. So this becomes a very nice syntax. Now in this case, of course, if your lambda is multi-line, it doesn't disrupt the flow. So as a result, I would say this is probably the only exception I follow to the rule of saying don't write multi-line lambda, maybe except when it's hanging as the last one. Maybe that's not that bad really at that point. So in this example, of course, we have a special treatment for the lambda. You can put that in the parameter list, argument list, but why would you? You can put it outside without the comma, so that becomes a lot easier to work with. So that is basically what we saw here is a little special treatment for this lambda that we can gain from. So now that we saw how to use a lambda, let's talk about some very common functional programming functions. Now, typically speaking, if you are programming in the imperative style, what do you normally use? You use for loops and use if statement and while statement and so on. Now, some of the times, programmers come to me and ask, hey, you're programming in functional programming, you use filter, map, and reduce and things like that, but what if I need something else, they ask. A really good question, reasonable question, what if you need something else? But let's step back and ask the question. When you program in imperative style, what are the things you normally use? You use things like if and else, you use for loops, you use while, and these are the structures you find in any language that's imperative. It doesn't matter whether you program in C or Java in the imperative style or C# or Ruby or Python, you have these constructs. You have a for, you have an if, you have an else. Now, what if I need something else? Well, you say, gosh, you're not going to need anything else because these are the primitives of the imperative style of programming. These are the primitive operations of imperative style of programming. And it's absolutely phenomenal that you can solve any problem with these few structures like for and if, else, and things like that. Similarly, in functional programming, the filter, map, and reduce are the primitive functions of functional programming. And you can solve almost any problem with a combination of these functions very effectively. So as a result, your tools of the trade really, just like for and if and a while, you have filter, map, and reduce available to you. So let's talk about filter. How does the filter really work? So to understand this, let's take a list of numbers. We'll call it numbers is equal to, and let's say list of, and we will go ahead and take a list of numbers, let's say 1 to 10 right here, and I want to get only the even numbers in this collection. So what I can do is I can print the numbers out, and you can see that it's all the numbers in this collection. Or we can say print line numbers dot filter, and then I'm going to hang it outside like you can see here, and I can say it mod 2 is equal to 0. So this gives you all the even numbers in the collection rather than all the numbers in the collection. So that becomes your filter operation. So how does the filter actually work? A filter works like the gate in a garage. So a car pulls in, the gate may open to let the car in. And another car pulls in, it may let the car in. A third car pulls in, it doesn't open because this person doesn't have permission to go, and they have to go elsewhere. So this is going to select and unselect and decide to let one value or not. Another way to look at it is, if I give you a bunch of coins, and if I ask you to only give me the dimes in these coins, you can take a little coin sorter, you can pour the coins over it, all the dimes will fall down, and the rest of the coins are held behind. That's basically how a filter is working. So a filter is going to let some values go through and hold off other values. And that's an example of how you can use a filter. Now there are some characteristics of a filter if you really think about it. If you think of a filter, A filter takes a predicate as a parameter, and a filter will give you 0 or 1 or more all the way up to all the elements. For example, if I say raise your hand, and you don't have to do it, but if I say raise your hand, if you're older than 1 year of age, I'm hoping everyone in this room will raise the hand because everybody here is older than 1. So that is all the elements. The filter gave everything. On the other hand, if I say raise your hand if you're older than 120 years of age, I'm hoping there's nobody in this room who is older than 120. And if you are, you're looking pretty darn good. But the point really is that nobody is older than 120, so the filter will block everything and nothing comes out. But if I say raise your hand if you're older than 50, some of us will raise the hand, others won't. So there'll be less than the full value, but greater than 0. So that's how filter is working. Map, on the other hand, will give us an ability to transform objects in a collection. So in this case, I can take the filtered value, but I can perform another operation with it. I can say, given these values filtered, perform a map, and given it times 2, double the values which are even in numbers. So when I run this code this time, notice from the output that you're getting, it is the double of all the even values in the collection. So we have done the filtering, but we perform the map up after that. What are the characteristics of a map? Well, the number of input is the same as the number of output in the case of a map. So if you have 7 elements coming in, you're going to have 7 elements going out. However, the type of the output may not be the same. The map may give you double values given integer, or a string value given an integer. If you give me a collection of strings, I can give you a collection of length of the strings, collection of strings to collection of int, for example. So there's no guarantee of the type when it comes to maps. On the other hand, the count will be the same moving forward, and that's an example of using a map function. Well, then comes along the reduce function. A reduce function is useful to take the collection of data and reduce it to a single value often, but could be a collection as well. But a reduce is often a termination of this sequence of operation. You can reduce it. Well, there are different reduce operations, but one special is called the sum operation, which is also a reduce. And this, of course, is taking all the even numbers, doubling them and performing the total. So this gives you the total of all the, double of all the values in the collection, even numbers that is, and that's what you're getting. And sum is one example of a reduce. But you can use other reduce functions, just reduce it, and you can pass a function to it with multiple, 2 parameters, and that becomes a reduce operation that you can really use. And depends on what you're doing, you can have different kinds of reduce operation. But having said that, I want to talk about one other thing that will be very useful for us. And before we talk about it, let's understand a little bit about map. So when it comes to map, there are 2 kinds of functions we typically use. Now, when it comes to these functions, you need to choose what kind of map operation you want to perform. But before we do that, pardon me, let's talk about one thing here. So let's take numbers is equal to list of, and let's go ahead and take a list of numbers again, 1 to 10. So given this list of numbers 1 to 10, let's go ahead and say that we are interested in taking these numbers and transforming it. Let's say we have a collection of numbers for a minute. So if I say 1, 2, 3 is the numbers I have, I can clearly ask for numbers.size. And there's no confusion, its numbers is 3. But if I, on the other hand, create a list of 1, 2, comma, and list of, let's say, 3, 4, and 5. What is the size of the numbers? Well, we know that the size of numbers is going to be 2 at this point because it's a list of lists after all. And if I were to print the numbers, you will notice that the numbers really is the list of lists you got. But on the other hand, you can also do something else. Val flattened, let's say, numbers. So flatten numbers is equal to numbers.flatten. I'm going to flatten it, then print out flatten numbers.size. But I'm also going to ask it to print the flattened numbers. What does flattening really mean? Imagine you're working with a small child at home, and you walk into a room, and there are books all over on the floor. And the books on the floor, there's one book, next to it there's two books, next to it there's three books, and then there's two books, and there's four books, and you're seeking the help of the child to organize it, but you want to sort the books as well. Well, you tell the child, hey, take all these books and flatten them on the floor. Well, what does that mean? Well, you take the book one, leave it like that. You take two books and move them next to each other. Take the three books and put them flat on the floor. So flattening is you take a list of lists and you flatten it out. So if you run this code this time, you can see from the output that you get, you have flattened it into one collection. So you have a 1, 2, and 3, and 4, which is the list of lists, and you flattened it. So you have 5 elements, which are 1, 2, 3, 4, and 5, all as part of this one list. That is a flatten operation. And I want you to keep that in mind for a few minutes about what flatten really means. So now that we talked about flattening, let's talk about something a little bit more complex. Talk about maps for a minute. When you think of a map, I want you to think of two kinds of functions. A function f1, which is a one-to-one function. So what does a one-to-one function mean? You give me one input, I'll give you one output. It's a one-to-one transformation. And on the other hand, I'm going to think of a function f2, which is a one-to, let's say, a many function. So one-to-many functions, on the other hand, are functions where you give one input, I'll give you many output. Let's look at some examples. If I say, we have people in this room, and I say, I want your first name. Well, that's a one-to-one function. Given one person, I have one first name. Input is person, output is a string, which is the first name. That's a one-to-one transformation. Or I can say, given a person, I want all your email addresses. Not just one of them. I want all of them. Why? Because it's much fun to spam all your email addresses than to spam one of them. So I want a collection. I want you to give me a collection of all your email addresses. That is a one-to-many transformation. Now what's going to happen? Well, unfortunately, though, if you take a list and you put a map and you pass to the map the function f1, what is the result of this? You get back a list. On the other hand, if you take a list and perform a map f2, what are you going to get as a result? List of list versus a list of elements. So in other words, map will perform literally the transformation. So you go from a list to a list when a map is given a one-to-one function, and you go to a list of lists when you go for a map with a one-to-many function. Very easy to see this. So let's go ahead and say we have a list of numbers. So we'll say numbers is equal to, let's say, list of 1, 2, 3. Now I want to say output numbers.map. Given an element, I'm going to say return element plus 1. So this is a one-to-one function. Given a e, give me e plus 1. So that's very easy to see. You just got a list as a response. So what is the output? It's a list. So list to a list. On the other hand, if I say numbers.map, but given an element, return to me a list of element minus 1, comma element plus 1. So I'm going to give you a list of before and after. This becomes list of list, isn't it? So when I run this code, you will notice from the output that what I got as a result is a list of list. Now, if that's what you wanted, that's awesome. You are done, you can go home. But what if you don't want that? What if you really wanted? So what if you have a one-to-many function, but you don't want a list of list, but just a single list. Well, if you just want a single list, what can you do? You will map it, and then you will flatten it, isn't it? Let's see if that works. So here's what I'm going to do. I'm going to take numbers, and then I'm going to say map, given an element, list of e minus 1, comma, e plus 1. Let's start with this baby steps first of all. So when I run this code, the last output is the same as the one before. That's exactly what we got. But I don't want a list of lists. So what am I going to do? I'm going to take this value and I'm going to do a flatten on that. That's what I'm going to do, isn't it? I'm just going to flatten it. So by flattening it, what am I going to get right now? So when I run this code, you can see that I got a flattened list. So I don't have a list of lists, I just have a list. So that's great, isn't it? But what is the disadvantage? The disadvantage is I had to map it and then I had to flatten it. But that's 2 steps. Why can't I combine them together? That would be really nice, isn't it? So in other words, if you have a many to many function, but you want a list and not a list of list as output, then use. So what should you really use? Well, let's think about this for a minute. If I want to combine these two, in functional programming, you want to merge these 2 functions into one. Remember what we talked about? We can combine functions to create bigger functions. If that's what I want to do, I want to map it first, and then I want to flatten it. So what I really wanted was the following. I wanted map flatten as one function. Now, okay, map flat I want. Now, I want you to do this experiment. I know this is odd, this is awkward, and if you don't feel comfortable doing it in public, I recommend you try this alone, when nobody is watching. Try saying map flat. Just try it out a little bit. Map flat. What did you notice? It hurts over here, doesn't it? Map flat. Now imagine the functional programmers created map flat. 300 years later, you will see some humans with deformed jaw. And they will look and say, you must be a functional programmer. How do you know? Because you look weird with your jaw deformed. These people saved humanity. They realized map flat is going to end up more dental work for people. So they saved the world by calling it flat map. Now say that aloud. Flat map. See how it rolls off the tongue? Flat map. So this is why they called it flat map. So flat map is actually map flat. But thankfully, they called it flat map. So, but when you're doing flat map, you're really mapping and flattening it. And so when you look at the output of this, you notice that's exactly what you got. You mapped it and you flattened it. So flat map is really for one-to-many functions. So when you have a one-to-many function, you want not a list of lists as an output, but you only want a list as output. Then you use what is called flat map. So a flat map is useful for a one-to-many transformation. So this is something you can remember in your mind. Use map for one-to-one, use flat map for one-to-many, when the result should be combined into one flattened map, and that's what you're going to use for that purpose. So that gives you an idea about how we can use that very nicely, and hopefully that gives you an idea about what and when to use a flat map. So flat map gives you that ability to smooth out the collection. Now, having said that, there is one other small detail, maybe not so small, we need to be really aware of. And that is, what is the cost of evaluation? What is the expense? How much work are we going to do? So to understand this, let's take some numbers is equal to, and in this case, list of 1, 2, 3, 5, 4, 6, 7, 8, let's say 9 and 10. But the problem I'm going to give you is the following. Find the, let's say, a double of the first number greater than 3 and is even. So if I give you this problem, find the first number greater than 3 and even, but find a double of it. Let's do it with our human eyes and hands. What would I do? Is 1 greater than 3? No. 2? No. 3? No. 5? Oh yes, 5 is greater than 3. Is 5 even? No. Is 4 greater than 3? Yes, it is. Is 4 even? Yes. Double 4, we got a result 8. Stop. You are not going to touch 6, 7, and anything after that. So that is efficient if we do it that way. Now let's see if that actually is true. So let's create a is greater than, which takes a number integer, and it's going to return n is greater than 3. I'm going to write a function is even, and the is even function takes a number n, and it's going to return, let's say, n times 2. So with that said, what do n mod 2 is equal to 0. So with that said, what am I going to really do with this code? I want to call a print line numbers dot, in this case, filter, and I'm going to pass to the filter is greater than 3. And then I'm going to call a filter again and pass to it is even. And then finally, I'm going to call a map function and pass to it double it, where the double it function is going to simply say that it is going to take a value n, and it's going to return to us, let's say, equal to n times 2. Now, if I were to call this, I'm going to say dot find first. So I'm going to say first and return the first value from this particular collection. What does the result say? Yay, the good news, the result is 8. Well, that's great, the result is 8, but what is the amount of work we did? This is where the problem comes in. If I were to put an int over here, and then say in here, if I say print line is greater than t, is called for, let's say for, and I'm going to print the value of n. When I run this code, unfortunately, notice that it is going to call, of course I got to return the result, don't I? Return n greater than 3. So if I run this code, unfortunately, notice what it's going to do. It is calling the is greater than 3, what did I do wrong? Boolean, right? I'm sleeping at the wheel. So this is going to be a Boolean result, of course. So if I run this code, what it is doing is, it is going to call this function for every single value all the way up to 10. How sad that is. In fact, if you go a little further and try this, if I put a Boolean here also, and then of course if I were to return, let's say n mod 2 is equal to 0, but before I do that print line and I say is even called, let's say for, and I'm going to print the number for which it is called, you can see that all that expense that we incur, which is not what you really want to do, because that's not very efficient. But before we go further, I want to mention one quick thing over here. And that is, if you ask me what is really the essence of functional programming, and I'm going to say that functional programming is equal to, and I'm going to add in this case, it is functional composition plus the use of, so absolutely composition plus the use of lazy evaluation. So in other words, if you ask me, what about object-oriented programming? I'm going to say polymorphism is to OOP as lazy evaluation is to functional programming. If you want to do OOP, why would you bother if you don't have polymorphism? In the same note, I would say lazy evaluation is as critical for functional programming. So when you look at this example, it did all the extra work for us to throw most of it out. So I'm going to save this away here as from eager to. And what you can do, though, you got to be careful with this, is you can go in and say, yes, I do want laziness, and you put as sequence over here. And when you turn that into a sequence, when you run the code, you notice that in this case, you're not doing all that extra work. You did not touch any value past the value 6 at this point. So the sequence gives you laziness of evaluation. And so you don't want to be running on a list directly if you have a very large collection. And if you want lazy evaluation, you want to run it on the sequence rather than running it on the list, because then it is going to evaluate lazily. So using sequence as sequence in Kotlin gives you behavior like using streams in Java. In Java, you don't have the filter and map on list. You only have them on stream for a good reason, because they want those to be done only one way, which is lazy evaluation. Kotlin gives you the choice, but you got to be careful what you're using, otherwise you end up using the wrong stuff. So from eager evaluation to lazy evaluation, and so that becomes very efficient from the functional programming point of view. So that gives you an idea about how we can use sequences to get laziness. So with that said, Kotlin gives you a fairly decent amount of choice to do functional programming as much as other programming models. You have to choose wisely and apply them. If you're interested in downloading the code examples I showed you here, you can download them from my website right here. As I wrote it, I saved it. I'll zip it and post it in about 10 minutes from now. You should be able to see it on my site after that. And if you're interested deep into this further, please take a look at Programming Kotlin, which is right now in beta release. It'll be released within a month or two in a production release after that. So please take a look at it also. Hope that was useful. Thanks for coming.